All right, so we are going to do section 4.5. The warm-up just asks us to find the x and the y intercepts. You can do the first one, so you can pause it and do the first one on your own, and then I'm going to go ahead and do the second one. So remember, if it is an x-intercept, that means it is on the x-axis and it never moved up or down, which makes your y value 0. So you take your equation, so 2x plus 5, and you plug 0 in for y, because if it's on the x-axis, you absolutely know that y is 0. And then you solve it from here. So 5 times 0 is 0, so this entire term cancels. So that leaves us with 2x equals 10. Divide by 2, and x is 5. Now remember, x equals 5 is a line. We don't want a line, we want a point. We need an ordered pair, okay? So we need the ordered pair. What did we get for x? We got 5. And for y, we plugged in 0. So that is your x-intercept. That's the point where it crosses the x-axis, okay? We are going to do it again because we need 2 points to graph a line, and we're going to find the y-intercept. Similarly, when it's on the y-axis, it never moved left or right, which means that x is 0, so you just plug a 0 where the x was, and then leave the y the same. Okay, 2 times 0 is 0, so that crosses this whole term out, and that just leaves you with a positive 5y equals 10. Divide by 5, which gives you y is 2. Again, y equals 2 is a line. I don't want a line, I want a point. So we need an ordered pair. X was 0, we plugged 0 in for x, and we got 2 for y, so that is my y-intercept. That's where it crosses the y-axis. And those are your 2 points. Okay, do one on your own if you haven't already, and then we're going to move on. So we have so far been learning about relations, and we said relations are any kind of relationship between numbers. And now we're moving on to a specific relation that's called a function. Okay, so there's a little bit more, there's more rules in order to be a function than there are to be a relation. Anything can be a relation, okay? But in order to be a function, it has to follow a specific set of rules. So it's similar to like all squares are rectangles, but not all rectangles are squares. Because to be a rectangle, you just have to have 4 right angles and 2 congruent sets of sides. So this is a rectangle because it doesn't have as many rules as a square. A square has everything a rectangle has, except the sides are all the same, so there's more rules for a square, okay? Same thing to do with functions and relations. So anything is a relation. Any kind of relationship between numbers works. But for a function, there's more rules that we have to follow, so that's what we're going to learn about today. A function is a relation in which every element of the domain is paired with exactly one element in the range. It's a really wordy definition. It's a very complicated way of saying you cannot have a repeated x value. So every x can only be used once in order for it to be a function, okay? So we can't have repeated x's, and so we're going to look at the different ways that we learned how to represent relations, and we're going to figure out if they're functions. So we're going to look at tables, graphs, mappings, all those things that we did at the beginning of chapter 4. And now we're going to go back and say, okay, are these relations functions? And we're looking for repeated x values. If an x value repeats, then it is not a function. Okay, so identify if each relation is a function. I only care about x values. The y values can repeat all day long, and it doesn't make a difference to me. So I ignore my y's completely when I'm looking to see if it's a function. I just look at the x's. So I have 2, 4, 0, and 1. All of those x values are different, so yes, this is a function. Okay, all of the x values are different, so yes, it is a function. I don't care about the y's. It doesn't matter if those can repeat if they want, but not the x's. Okay, for number 2, again, if we're trying to identify it's a function or not, we look at the x values. So I have 10, 2, 12, and 10. So these 10s repeat, So this is not a function because those 10s were used more than once. Okay? When you are doing your assignments and you're telling me something is not a function, do exactly what I just did and somehow tell me why. You can write out that the 10 repeats, or you just highlight them, but somehow indicate to me that you know why it's not a function. Okay, so highlight or circle or write it out exactly what repeats and why, what makes it not a function. All right, number 3 is a mapping. So you look at your X oval and you're looking for anything that might indicate a repeat. Okay, 2 only maps to 7, so that doesn't seem to be a problem. But 3 has 2 arrows coming out of it. 3 goes to 8 and 3 goes to 9, which means that the 3 is a repeated X value. So this is not a function. Okay, because 3 is repeated. You would have the ordered pair 3, 8 and the ordered pair 3, 9, which doesn't work in functions because your X's are repeated. All right, we want to try to figure out a fast way to be able to tell if a graph is a function by looking at it. So let's start with the red one, and it says just to pick some points and see what it's looking like. Okay, so these horizontally are on the same line. This point on the left is -2, 1, 2, 3, 4. The one on the right is +2, 4. Just looking at those 2 points, my X values do not repeat. So that doesn't seem to be a problem. If you look at this side to side, these X's are never going to repeat, okay? The ones over here only happen once, and then over here they're just going to be negatives. So the red one is a function, okay? So the red one, we'll color code. The red one is a function. None of those X values are going to repeat. If we look at the blue one, we can pick this point at the top is 1, 1. Down here, we're at 1, -1. 2, 2, 2, -2. This time, my X's are the same, but my Y's are going positives and negatives. But the fact that the X's are the same on even one point, all of these X's are the same. Okay, that doesn't have to be the case. Just one of them has to overlap. And since these overlap, then this is not a function. Okay, if any of the X's end up being the same, then the graph automatically is not a function. It doesn't have to be a repeated pattern like this one is. It could be anything. As long as they repeat, not a function. So we look here. Hopefully we can tell by looking that the red one has 1, 2, 3. This is a -3, 4. And the one down here is -3, -1. They are on the same vertical line, which makes them have the same X value because they both went to the left 3, which is that line, and they overlap. So those X values are repeating. So the X is a repeat, so the red one is not a function. Okay. The blue one, you can pick a bunch of points if you want, but if you look, this is going to be -1, -1. This is a +1, -1. Okay? -2, -2. This is a +2, -2. These are different X's because horizontally they go in different directions, and so they never line up on top of one another. So this blue one is a function. Okay? So if we're just looking at a graph, you can kind of see that if they are on top of each other on the same vertical line, then they're not going to be a function, okay? because they're going to share that same x value. So these overlap in all these places. Okay, all of these have the exact same x values all the way through because they line up vertically on top of one another. Okay, so that's what we're going to use. Instead of having to pick a bunch of points, we can use what's called the vertical line test. And you just practice by dragging a vertical line across the graph, and if it crosses in more than one spot at any point, then it is not a function, and you can just stop right then. Okay? So the patterns that we're finding is that if they're on top of each other, then they are not going to be a function. So that's what's called the vertical line test. Okay? You pretend like there's a vertical line along the entire graph, so you pull it. If the line touches the graph in more than one place, then it is not a function. Okay? More than once, it's not a function. If it makes it through the whole graph without touching in more than one spot, then you're fine, and yes, it is a function. Okay? This orange line, it was just supposed to be my vertical line, but it doesn't work on this. So I'm going to just make myself a new one. Okay? So there's my vertical line. I'm going to drag it across this graph. Okay? As I'm going, I'm looking to see if it ever touches in more than one spot. The second I even cross a little bit, I can see that this graph overlaps on top of each other. This vertical line is touching in more than one spot right away. Okay? So that means this is not a function. When you have these on your homework, you just have to do the same thing. Just draw me a vertical line and circle where it overlaps. Okay, because this one overlaps a lot, so we could have a lot of them, but you only have to point out one of them. Okay, this one, we pull it across, and even though it looks like it might be tricky, you can see that it's consistently going outward, so those points, even though they look close to each other, are still all going to be different. This graph never really sits on top of itself, so you can pull this vertical line all the way through, and at no point does it cross more than once. So it passes, it got all the way through, so yes, this is a function. When you are explaining why, you could just tell me it passes the vertical line test. You can just say passes VLT because there's nowhere you can point out a mistake, so you can just tell me, oh, this one passed the vertical line test, so that means that's why I'm telling you yes. Okay? This one, pull it across, and right away we see it sitting on top of each other. So they are overlapping. So it crosses in more than one place, so this is not a function. Again, you can just do exactly what I just did. You can draw a vertical line and circle or highlight where it crosses more than once and tell me not a function. Or you can do it and tell me it failed the vertical line test. It's the same thing. It's demonstrating it with words versus showing how it fails. Either way is an acceptable response. Okay? Now, be careful with lines. So this line... the red line, it's fine. It goes all the way through. It doesn't seem to overlap at all. Okay, so this original line is a function. If let's just take my vertical line and make it a part of the graph. So if I make a horizontal line, okay, first of all, let's talk about the equation of that horizontal line. I'll change the color. Okay, so the pink one, the equation of that line is y equals 2. You know how to do your equations of your lines, so all horizontal lines have an equation of y equals. They don't have an x in them at all because every single y value on that graph is 2. All of these points are up at 2. Okay, the x's change every time, but the constant is the y value at 2. So the equation of that line is just y equals 2, and it passes my vertical line test just fine. I can drag something across that all day, and it's not a problem. Okay, let's just change the color of this one. Okay, So let's say that this vertical line is over here. That equation of the blue line would be x equals, because it's a vertical line, 1, 2, 3, 4, 5, -6. Because every single x value is at -6. Vertical lines do not pass the vertical line test. They can't pass their own test. They are the epitome of failure. Every single one of these points has the exact same x value. The whole line is on top of itself, okay? Hence, the equation x equals -6, every single point on that line has a repeated x value of -6. So all lines are functions except for vertical lines, okay? So there's a part of your homework where they give you equations and they ask you if it's a function or not. So you have to think back to our other equation, so it says 3x plus 5y equals 7, okay? Remember our questions to see if it's a line. Are x and y being raised to any powers? Are x and y on the bottom of any fraction? Or are x and y being multiplied together? The answer for this is no, 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 which means it is a line. It has both an x and a y, which means it is a normal, slanted, somehow normal line, okay? So normal lines are all functions. So this one would be a yes, because it's a line, okay? If I have a y equals a number, that is a horizontal line, okay? And yes, horizontal lines are functions, okay? If the equation is x equals a number, that's not a function because that is a vertical line, okay? So just be aware on the homework, if it is a normal linear equation with both an x and a y, that's fine, that's a line, that's a function. If it's only a y equals a number, that is also a function because all horizontal lines are functions. But if it's just x equals a number, that's a vertical line, and that's the kind of line that is not going to work, okay? So just keep that in mind when you do your assignment, which is your 4-5 worksheet, and let me know if you need anything. Bye, guys.